Okay, so I realized that I didn't show you how to compute the coordinate of of the addition of 2 points over an elliptic curve. Okay, so let us remind a little bit what we have done in this subject. So we have an elliptic curve. Okay, we have already talked about that. You know, this is how it looks like over R. But if you think of the rational points modulo some prime, then it looks a much more. I mean, we have no without any order. Okay, so we said that I mean if we have two different points like P and Q, and we want to find a P plus Q, so we take the ray starting from P, and this line has a third point intersection, and we reflect this point. I mean, we take the same X but minus Y, and this will be the sum of P and Q. Why do we reflect? Because we want it to have a group structure. So if we compute P plus the neutral element, which is infinite, so the sum will be actually minus P, because P plus minus P, okay, I mean P plus O will be this line, okay, and P plus O, if you take the line and just take the third intersection, then it wouldn't result in P. You want P plus O to be P, so you reflect, and then P plus O turns out to be again P. This is what we want because this is the neutral element. Okay, but now how do we find, I mean, the coordinates of R? So we have two cases. One case is when P and Q are distinct. So we have to find the slope of this line. Okay. So how do we? Okay. So let me write it. You still see, isn't it? The guy.
Yeah, I see.
So if P, which is not Q, are 2 points over C, C is in affine coordinates is something like this. So we have P is XP YP, and Q is XQ YQ. Okay. Okay, so how do we find? Okay, so the slope of this line, okay, suppose this is a y lambda x plus b, okay? So this is the slope of this line. So lambda will be just as ordinary delta y divided by delta x. I mean y p minus y q divided by x p minus x q. Okay, so we found a lambda. Now we want to find this point, and then to reflect, it's not a problem. Just take the means. Okay, so I mean, what we because this line, I mean, if we take its square, I mean, it satisfies the elliptic curve. Okay. No, it's not the same b. So let's just call it lambda here. There's nothing to do. Okay. Now, so we actually get a 3-degree polynomial. I mean, and we actually want to find its root. Okay, so we know, I don't know if you know that the coefficient of x.
I joined now. I didn't see that.
Yes, it's my fault. I apologize. I don't know. I wanted to write 5 and I've written 520. I'm very sorry. Okay, it's my fault.
Okay, I see it's recorded, so I'll go over it.
Yes, I just want to show you how to compute the coordinate of the addition of 2 points over the elliptic curve. So if P and Q are distinct, okay, so this line, which is slope, is easy to compute. It's just delta y divided by delta x. I mean, we know 2 points. We know, okay, so we find lambda. Now we want to find the point here. Okay, so what is this point here? We know that, I mean, so we compare between this line square with a y square of the elliptic curve. And if we move it to the left hand of this equation, we get actually this polynomial, which has, of course, 3 roots. And these roots are distinct because the P and Q are different. Okay, so we know that x of P plus x of Q plus, let us call this point R, plus xr is actually minus the coefficient of x squared. You know that? I mean, it's always true in any polynomial. If you take the coefficient of the one less most, one less of the degree, the coefficient of it is the sum. I mean, minus the coefficient is the sum of the x. Okay, so this is okay. So this is no. So we have now x r. Okay, so this gives us the x. Okay. Now, in order to find the y, it's just to put it on the line. I mean, because of course, again, delta y divided by delta x is the same slope. Okay, so this is how we find r, and then we do minus y in order to get the reflection. So this is when P and Q are distinct. When they are the same, for example, if we want to add P to itself, okay, so it turns out to be a tangent. If this is P, okay, then its tangent gives okay, so this will be 2P because, so how do we find this R? Okay, so now, of course, we don't have 2 points, we have the same points, but now we can just do a derivation. I mean, if the line is as before, okay, then and of course it is and still R is on the intersection with C, okay. So what is C? So if we derive, we get y tag, which is lambda. Now we put the P. Okay, so this is how we find lambda in case we want the tangent, not the when P is different from Q. Okay, and the rest is the same. Okay, from here it's the same. I mean, you find I mean, once you have lambda, then again, okay, you are doing the same thing. I mean, lambda x plus. Okay, so again, 2xp plus xr is lambda square. So, okay, so you find the XR and then you find YR. Okay, so I remember that really it was you that asked a very nice question. I mean, even if we want to cook, if we know the power of the generator, it's not easy to compute in this way. I mean, n time p, because it's iterative. I mean, but we have methods for that. I mean, if we want to compute, for example, x 100, then we don't do that 100 times. I mean, we find what is x squared. And once we find x squared, I mean, it's all modulo, of course. Okay, so then it will be I mean, it's square. So in this way, okay, I mean, he will talk about it, Tomer. Okay, for example, let us take a simple example. If you want to compute x10, okay, so you do x2, and then you make it a square, and when you make it a square, it's just okay. So this is much. I mean, once you know what is x4, so it's easy to find. I mean, x8. Okay, so you don't really do 8 times. I mean, you find stations in all over the. Okay, so but Tomer will talk about it. I'm sorry, I must run because I have some exam that I have to be there. Okay, so this is how we compute. In anyway, last thing, Tomer has changed. I mean, the project. I mean, it changed the essence of the project, but he put some extra details in order to make it more understandable. So I hope that this will be better. Anyway, he will talk about it now. So I have to leave. Thank you, and we will meet in the presentation of the project. I'm sorry, I have to leave. Bye.
Thanks, bye.
Thanks.
Thank you. Bye.